Here we have a problem from 13.6 where we have been finding the area under the normal curve. And in this problem we're going to assume that math scores on the SAT are normally distributed with a mean of 500 and a standard deviation of 100. And we want to know what percent of students who took the test have a math score that's below 630. So what we want to do first is change this. We have a mean of 500, standard deviation of 100, and we want to find the z-score associated with the piece of data that would be the 630. So let's find the z-score of 630. Remember before when we found that the formula is the piece of data, so 630 minus the mean was given in the problem, 500, divided by the standard deviation, and that was also given to us in the problem. Standard deviation was 100. So 630 minus 500 would be 130 divided by 100. And we can reduce that a little bit, or you can go ahead in your calculator and take 130 and divide it by 100, or reduce it and then type it in the calculator. 13 divided by 10 should give me that same value of a positive 1.3. And we could have done that without the calculator as well, 13 divided by 10. But we would have a z-score for that data piece of 630 of 1.3. So let's look at that on the curve, and then we'll look to our table to see what area is associated with it. But on our standard curve, remember that the mean is in the middle with a z-score of 0. So z-score of 1.3 doesn't matter exactly where you put it, but we know it's to the right of the mean. And it says what percent of students who took the test have a math score that is below 630. So that would be below. Remember that this was the data piece 630. It has a z-score of 1.3. So we're looking for this area. And remember that the tables that we're going to look at always do give us the area below the curve. So let's go back. As we look at our table, let's look for 1.3. 1.3 and it's 1.30. Now I didn't include all of the decimals here, but this is your 1.3. And remember that would represent the area below the z-score of 1.3 that's under the curve. So this area is 0.9032, and we've been asked specifically to give the percent of students who have a math score below 630. So that as a percentage, we'd multiply by 100 and get 90.32%. So 90.32% of the students who took the test have a math score below 630. Now let's look at this example. It says a vending machine is designed to dispense a mean of 7.5 ounces of coffee into an 8-ounce cup. If the standard deviation of the amount of coffee dispensed is 0.4, so 4/10 of an ounce, and is normally distributed, find the percent of times the machine will dispense from 7.3 to 7.8 ounces. So what we want to do is look at that on the curve. We want to find, first of all, the area between these two pieces of data, and then we will change that to a percent since we were asked to do that in the problem. Now to find area under the curve, we need z-scores. So let's find the z-scores of these pieces of data. We know that 7.5 as a data piece would have a z-score of 0. So let's look at 7.8, and then we'll find a z-score of 7.3. We do that by taking the piece of data minus the mean divided by the standard deviation, which was given as 0.4, So that would be 0.3 divided by 0.4 in our calculator. 0.3 divided by 0.4 is equal to 0.75. So the z-score for the 7.8 ounces is 0.7075. Let me go back. Our calculator gave 0.75. So here we've got a z-score of 0.75 for the 7.8 ounces of coffee. And then 7.3, let's find the z-score for that one. So 7.3 minus 7.5 divided by 0.4 would give me a negative 0.2 divided by 0.4, which is a negative 1/2. You can do that in your calculator, or as you simplify, see that 0.2 over 0.4 is a negative 1/2. So the z-score here would be a negative 0.5. That was the 7.3 ounces. Okay, but these are my z-scores. And we want to find the area between those two z-scores, which is here. So we first need to find, remember that as we look at our chart, our table, it's going to be, we would want to find the area to the left of 0.75, but then that would give me all of this area. So then we're going to have to take out the area below or to the left of the negative 0.05. So let's find the area first using our chart. To the left of a z-score of 0.75. So for 0.75, we would go here. And it looks like the area to the left of 0.75 equals 0.7734. So that would be all of this area to the left, including this blank part. We don't want that. So we want to subtract the area to the left of the negative 0.5. So the area to the left of negative 0.5 is 0.3085. But remember, we want to subtract those values. So let's look in the calculator. 0.7734 minus 0.3085 would give me 0.4649. So the area between those two z-scores is 0.4649. We were asked to find the percent of times the machine would disperse, so we want to change that to a percentage, multiply it by 100, of 46.49%. So that would be the percent of times the machine will dispense from 7.3 to 7.8 ounces. Here we have another example, and it's a little bit different, so let's pay attention to the question that's being asked here. It says the speed of cars is normally distributed with a mean of 64 miles per hour. I've indicated that on my bell curve, normal curve. 64 miles per hour is the mean, so it has a z-score of 0 and a standard deviation of 10 miles an hour. So you could mark, we don't have to put it on here, but at one standard deviation, it would be 10 miles per hour greater than the mean, so 74. And at -1, or a z-score, that would be at a z-score of 1, A z-score of -1 is one standard deviation below the mean, so that would be at 54 miles an hour, just so you get a little bit better picture of the spread there. We're asked to find if 1,000 cars are selected at random, how many will be traveling slower than 51 miles an hour. So that's way down here. We need to find the z-score. So let's find the z-score at 51 miles an hour would be the piece of data 51 minus the mean of 64 over the standard deviation of 10. So that would be a negative 13 over 10, or negative 1.3. Do it in the calculator, or just know that when we divide by 10, we move the decimal place to the left one place. So the z-score here for 51 miles an hour would be negative 1.3. So we're looking for how many cars are slower than that. We're going to find here first the percentage of area under the curve, and then we can find the number that they're looking for. So we want to find on our table the area of curve under the curve to the left of negative 1.3. So using the table, negative 1.3, we knew that it would be a very small percentage or a small area under the curve. It is 0.0968. That's the area to the left of the z-score negative 1.3, which was our piece of data of 51 miles per hour. Now, the percentage, let's say that they had said, what is the percentage of cars that are traveling slower than that? The percentage would be 9.68%. But they've asked us here, if 1,000 cars are selected, how many will travel slower? So how many we would get by, it's 9.68% of 1,000. So we would want to actually use the decimal form and multiply that by 1,000. You can in your calculator, or we could actually move the decimal point over 1, 2, 3 places, which would give me 96.8 cars would be traveling slower than 51 miles per hour. So you always want to look at that last question to see, are they asking for area? Are they asking for the percent? Or are they asking for the number of a particular piece of data? And you might be asked to round to the nearest number of cars, which would be actually 97 cars.